so let's investigate this property of polygons and a way to calculate the sum of the interior angles of any polygon. Typically used for convex polygons, but it actually works for any polygon, even if it's concave. But we're going to deal with convex. So we already know that a three-sided polygon, aka triangle, the sum of the interior angles of a triangle is 180. We know that. Okay. Now, so let's deal with a quadrilateral. Boom, 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 boom. Okay, we got this irregular quadrilateral. Looks like the name Hitchhat, by the way, but who cares? So we want to know, what do these four angles add up to? Well, let's do something here. I'm going to construct a diagonal. I'm just going to draw in a diagonal. Okay. Now, so let's call this angle measure A. We'll call this measure angle B. This angle measure is C. And we'll call this one D, and this one E, and this one F. Well, what does A plus B plus C equal? A plus B plus C equals, those are the angles of a triangle, so that's 180. And the same thing with D plus E plus F. That's another 180. So the four angles of the original quadrilateral would add up to A plus B plus C plus D plus E plus F. So that will be 2 times 180. So I'm just going to type in 2 times 180 because I'm not looking for, I'm trying to develop a formula here, not that's equals 360. We know that, but the reason I'm leaving it at 2 times 180 is so that a pattern will emerge. All right, so let's get rid of this quadrilateral. So that was for a quadrilateral. Okay, let's make a pentagon now. Oops. 1, 2, 3, 4, 5. All right, now I'm going to once again put some diagonals in here. All right, from one vertex, I'm going to pick this vertex here. Oops. So from this vertex, I'm going to draw, I can draw one diagonal, two diagonals from that one vertex. Okay, and look, I've got A, B, C, D, E, F, G, H, I. Well, A plus B plus C, that's 180 again. D plus E plus F is still 180, but now I've got G plus H plus I also equaling 180. So now I have 3 180s inside all of the angles, because the 5 angles would be the sum of those 9 angles. The 5 interior angles of that pentagon will be the sum of the 9 interior angles of those triangles. So if there are 5 sides, if it's a pentagon, then 3 times 180 is the sum of the interior angles. Okay, I'll go one more step. Let's do a hexagon 6. And tools, irregular. Oops, come on down. Tools. 1, 2, 3, 4, 5, 6. Hexagon. All right. I'm going to pick a vertex and draw all the diagonals that I possibly can from that vertex. I'll use this one. So I can draw, oh wait, that's a pentagon. Darn it. Let's try this again. Now I've got a hexagon. Okay, I will choose this vertex to draw diagonals from. Diagonal, diagonal, diagonal. Hopefully you already see what's going on. A, B, C, D, E, F, G, H, I. I don't know why I capitalized that one. J, K, L. Well, I've still got those three things going on. Plus I got J plus K plus L also equaling 180. So inside the hexagon, there are 4 hidden triangles, and the interior angles of each of those 4 triangles is 180. So 4 times 180. So if the triangle has 7, if the polygon has 7 sides, it will be 5 times 180 would be the sum of the interior angles. And I could change this one. I could change this 180 to, I could make it 1 times 180 because it's a triangle. So the sum of the interior angles, the sum of the interior angles of a polygon is the number of hidden triangles times 180. The number of hidden triangles, if the polygon has n sides, then how many hidden triangles will it have? It will have 2 less than the number of sides. The number of hidden triangles is 2 less than the number of sides. And each of those hidden triangles has 180 degrees inside. And that's a simple explanation for this formula right here that is so super logical that you don't need to waste brain space memorizing that. Think about hidden triangles.